Hello guys, Benjamin here. In this tutorial, we will be learning the basics of stoichiometry. To put it simply, stoichiometry uses mole ratios to study the quantitative relationships between reactants and products of reactions. We use it to estimate the amount of reactants required for a reaction and how much products we could theoretically obtain from a reaction. The law of conservation also comes into play, as the mass of reactants must equal the mass of products. Here are some key concepts to know: mole ratios, excess reactants, limiting reactants, and percent yield. The definitions are on the board, so feel free to pause the video if needed. Here's a simple demonstration of the concept. So solve for moles of B if 3 moles of A were to react with an excess amount of B. To solve the question, we first know that 3 moles of A were given on the prompt, so we write it down. Since we are trying to solve for the amount of moles of B using 3 moles of A, we look at the chemical formula to find out its molar ratios. So for every 1 mole of A, there are 2 moles of B, and we multiply to get 6 as the final answer. So basically what's happening here is that if 3 moles of A are reacted, the moles of B must be double that of A. This means that 6 moles of substance B are required, assuming an excess of it is available. Alright, let's get started on some word problems. How many grams of water are produced when 4 grams of hydrogen gas react with excess oxygen? Alright, so first we outline the chemical equation, then we balance it, and then we write the states of matter. 4 grams of hydrogen gas are given, so we plug it in and convert it to moles. And finally, we use mole ratios to determine grams of H2O produced. So basically what my work is saying is that there are 2.02 grams per 1 mole of H2. And in the reaction, every 2 moles of H2 produce 2 moles of H2O, and in 1 mole of H2O, there are 18.02 grams, and you should end up with around 35.68 grams of H2O. How many grams of aluminum chloride are produced when 25 grams of aluminum metal react with 115 grams of chlorine gas? What is the limiting reactant, and how much of the excess reactant is left? So first, we set up the chemical equation. Next, we plug in the first value, which is 25 grams of aluminum. By using stoichiometry, we convert 25 grams of aluminum to moles by dividing with its molar mass. We then use the mole ratio derived from the equation and then convert to grams of aluminum chloride. So we end up with 123.55 grams of aluminum chloride from 25 grams of aluminum. Next, we utilize the same process for 115 grams of chlorine gas. Eventually, we end up with 144.19 grams of aluminum chloride. Now when we compare the theoretical yields of the product from both samples, we can see that 25 grams of aluminum produce less, thus making it the limiting reactant. Next, we must figure out how much grams of the excess reactant is left, so we subtract the theoretical yield from the excess reactant by the theoretical yield of the limiting reactant. The difference is 20.64, so we convert this much grams of aluminum chloride into grams of the excess reactant, which in this case is chlorine gas. So by converting 20.64 grams of aluminum chloride into moles, using mole ratios, and converting it back to grams of chlorine gas, we find out that 16.46 grams of CO2 would be left after the reaction. Alright, I hope this tutorial has helped you. Have a good day and good luck with stoichiometry.